In 1932, the neutron was discovered, which paved the way for the entire concept of nuclear warheads. This is because, unlike protons and electrons, neutrons have no charge, so they aren't repelled when close to an atom. Now, 6 years later, in 1938, the concept of nuclear fission was found by two German scientists at the Kaiser Wilhelm Institute for Chemistry. Their thinking was that if neutrons weren't repelled by atoms, could you theoretically shoot neutrons at atoms to break them apart? And the answer was a resounding yes. But despite this information being basically invaluable to Nazi Germany at the time, the Nazi scientists who developed this theory feared persecution. And so word got around to America, more specifically to scientists like Albert Einstein and Robert Oppenheimer. And despite the significant time advantage the Nazis had, America was still the first country to develop actual nuclear warheads under the Manhattan Project. But I'm not here to talk about the history of the Second World War. No, I'm here to answer the question of how these weapons of mass destruction actually work. Okay, so there are two main types of nuclear reactions that create a big explosion: fission reactions and fusion reactions. With fission, you start off with some unstable elements or isotopes with a ton of protons like uranium-235, cesium-137, and strontium-90, and try to split the atoms apart by shooting high-speed neutrons at them. And this does two things. One, it releases some energy from the atom, and two, the isotopes release neutrons. The neutron will then find more atoms to release more neutrons, which releases more energy. But fusion doesn't work this way. So how does it work? Well, with fusion you take relatively simple elements like helium or hydrogen and heat them up to around 100 million degrees Celsius. This causes the protons to break apart from their electrons and go shooting off at extreme speeds, which causes new atoms to form and in turn releases a lot of energy. Much more than fission. But why is it the case that fission and fusion release energy in the first place? If you can't destroy or create matter, why would rearranging the protons in an atom release energy? Well, like last time, let's start with fission. So when an atom, let's take uranium-235 for example, is split by a neutron, the uranium is divided into two different elements. Let's take barium and krypton, a very common division product for uranium. Let's now add up the atomic mass of barium and krypton. Krypton's atomic mass is around 83.8 atomic mass units, AMU for short, and barium's is 137.3. And if we add them up, we get 221.1. But that can't be right, because uranium-235's AMU is, well, 235. So what happened here? Well, through Einstein's mass equation, the extra mass from the division is converted to pure energy, resulting in a release of energy, aka an explosion. But again, this isn't the same process used for fusion. So how does fusion, a much more devastating reaction, release so much energy? Well, it's a bit like the fission process, but just backwards. Starting off, you take a few atoms of an element with just a couple protons, like hydrogen, which has just one, and heat them up a lot. The protons will start to jitter so much that they actually fly off, and 4 hydrogen atoms will combine to create 1 helium atom. But if you're experienced with a periodic table, you might say, well, hold on, helium only has 2 protons to it. How can this happen? It's because the other 2 protons didn't actually stay as protons. They convert to positrons instead. These positrons act like a kind of antimatter to electrons. And so when a positron meets an electron, they both decay and produce energy, thus fusion. And the reason why fusion is so much more powerful than fission is due to the fact that you're able to cram a lot more hydrogen and helium atoms into a small space than elements like uranium-235. They simply take up less space. So yeah, fission releases energy by splitting atoms, and fusion releases energy by combining atoms. Thanks for coming to my TED Talk.